All right, let's get right into it. Today, we're looking at how network access control, or NAC, enforcement gets configured in different industries. You'll see that the setup is a direct result of two things: what devices are actually on the network and the specific compliance rules that industry has to meet.
So where does this analysis come from? Well, it's based on data from real-world Genian NAC deployments. We're talking about more than 5,000 organizations over a span of 21 years. That's the foundation for the patterns we're about to see.
Here's the core idea you need to keep in mind. NAC enforcement isn't some one-size-fits-all solution. The configuration has to mirror the exact environment it's protecting. The platform itself stays the same. It's the enforcement method that changes to fit the need.
We're going to break this down using 4 case studies. First, we'll look at the regulated world of banking and finance. Then, we'll jump into healthcare and its critical medical devices. After that, it's the industrial networks you find in manufacturing. And finally, we'll cover the very unique security needs of the public sector.
This quote really sets the stage. You see, source documentation shows that a leading cause of failure is just how complex these deployments can get. This reality is why having multiple, flexible enforcement methods you can apply over time is so important. First up, let's see how this all works in banking, financial services, and insurance, what we call BFSI. This entire sector is really defined by its super strict regulatory landscape and constant audit requirements.
In the BFSI world, the network is mostly made up of managed endpoints that sit inside these highly regulated zones. Now, to pass an audit, regulators demand very detailed records for every single device connection. They want the MAC address, the user who logged in, the physical switchboard it's connected to, and exact timestamps.
Okay, so the enforcement method is built to meet those requirements exactly. It's a sequence. It starts with 802.1x authentication. Depending on that result, the device gets assigned to a specific VLAN. For any real-time policy changes, something called radius change of authorization is used. And what about devices that don't support 802.1x? They're handled by other methods, all on the same platform.
And the outcome of setting it up this way? Every single connection event that auditors care about is collected in real time. This builds a detailed log that's always ready to be exported for any audit request.
Now, let's shift gears to our second industry, healthcare. Here, the challenges are quite different. It's all about patient care and dealing with a whole array of specialized medical equipment.
You know, the key challenge in healthcare is this mix of devices. You've got your standard IT computers and servers right alongside medical devices, things like infusion pumps and MRI machines. The thing is, you can't manage this specialized gear in the usual way. They often can't run security agents, they don't support 802.1x, and you absolutely cannot restart them while they're being used for patient care.
So, the enforcement method has to adapt to those constraints. The very first step is to identify every device on the network without having to install an agent. Then, an ARP-based policy is applied, which works across all these different device types. If a device that's out of compliance needs to be isolated, SNMP is used to shut down its specific switch port.
And the result? You get full network coverage for every single device. This is all done without installing agents, without restarting critical equipment, and without having to manage long, complicated MAC authentication bypass, or MAB, exception lists for every medical device.
Our third industry, manufacturing, actually shares some of these challenges. But here, the focus shifts to what's called operational technology, or OT. The top priority is keeping production lines running, no matter what.
So again, we see this mix of standard IT gear and specialized OT. We're talking about devices like PLCs and SCADA systems. And just like the medical devices we just saw, this OT equipment typically can't support security agents, doesn't use 802.1x, and absolutely cannot be taken offline during production hours. This presents a really critical choice for enforcement. If you use a strict 802.1x policy in this environment, you have to create a manual MAB exception for every single OT device. That turns into a huge, ongoing maintenance task. An ARP-based policy, on the other hand, can cover both IT and OT devices without needing that list of exceptions at all. The documented outcome here is all about speed and stability. Complete visibility across the entire network, both IT and OT, is established in just 2 to 3 days. And this is done with zero configuration changes to the existing network infrastructure.
All right, our final case study brings us into public sector and government networks. These environments have their own set of unique characteristics, mainly around strict network segmentation and big concerns about supply chain security. So, in the public sector, networks are often split into classified and unclassified zones. Then, procurement rules add another layer of complexity, requiring detailed tracking of a device's country of origin. On top of that, the data gathered about these devices has to meet tough security standards, like SLSA3 and NIST guidelines.
To handle all these different requirements, a combination of enforcement methods is used, all coming from a single platform. SNMP, port shutdown, provides hard enforcement for the high-security areas. ARP-based control is used for segments where that's not possible. And standard 802.1x takes care of authentication for the managed endpoints. It's really about using the right tool for the right part of the network.
The outcome is a security architecture that meets these very specific government needs. It's a fully on-premises deployment, which means no cloud connectivity is required. That's a critical security posture for many agencies. It also gives them a unified view of security status across all their different locations, all from one console.
So, we've walked through 4 very different industries. What's the one unifying principle that connects all of these different approaches?
It really just boils down to this. The right enforcement method is always a direct result of 2 things. First, what kinds of devices are actually on the network? And second, what does the organization have to prove to auditors, to regulators, or to its own internal standards?
And that is the key takeaway. A single, unified platform can apply different enforcement methods exactly where they're needed. The method changes to fit the specific needs of each network segment, but the underlying platform stays consistent.
This brings us to a final question, something for you to think about. When you look at your own environment, how well does your current enforcement strategy really adapt to the actual mix of devices, constraints, and compliance requirements that exist on your network today?